Hello everyone. Today we are going to see about the topic called watershed management in the course name Environmental Studies. So what is meant by watershed management? So first we will see what is meant by watershed. So watershed is an area of land where all the water that falls either from the rain or snow will drain into the common outlet like a river, lake or ocean. So this is also called as a drainage basin or catchment area. So what will be the key features of the watershed? All the rainwater in a watershed flows downhill and collect into a single water body. It includes river, streams, hills, valleys, soil, vegetation, and even the human settlements. The watersheds can be small like a village stream or huge like a Ganga or Amazon river basin. So the watershed management, the most of the water comes from the rainfall or the stormwater runoff. So the quality and the quantity of the stormwater is affected by all the alterations like land mining, agriculture, construction of the roadways, urban development, and the activities of the people with the watershed. So usually the watershed will be separated from other watersheds by naturally elevating areas. So why this particular watershed is very important to study because the surface water features and storm after runoff within the watershed ultimately drain to the other bodies of the water, and this water collected is a naturally collected water through the channelized rainwater system, and this will support the agriculture by providing waters for the crops and livestock, and this will support the biodiversity also include forest, rivers, wetlands, and support world wildlife and the human settlements. Many towns and cities depend on the watershed for the water supply, and the healthy watershed will prevent the floods, droughts, and the soil erosion. So we need to remember that we all live in a downstream that everyday activities can affect the ground stream water also. So what is meant by the management of watersheds? So the management of the watershed is a management of the environment has been primarily focused on specific issues such as air, land, and water. Most of efforts has resulted in decreasing the pollutant emissions of air and water. So this will lead to the improved landfills, remediation of the waste sites, and contaminated groundwater. And this will protect the rare and endangered species and the design of the best management practice to control water and contaminant runoff and much more. So this management So this watershed is an area of land and water bounded by the drainage divide within which the surface runoff collects and flow of the watershed through a single outlet into a larger river or lake. So in this image you can see, so there is a precipitation of rain and snow which falls on the major of the hill area, and there is a particular place which is here denoted in the yellow color where these waters will be collected, and it will be segregated, and it will be collected, and it will be flow into the particular area, and then it will move to a individual separate water body like a lake, pond, or river, and there if it is collected automatically it will be percolated and it will be filtered and it will reach as the ground water. So coming to the types of the watershed, what are the different types of watersheds? So these watersheds are classified depending upon the size, drainage, shape, and the land use pattern. So first is said to be the macro watershed, which will cover more than 50,000 hectares. And next is the sub watershed, which will cover 10,000 to 50,000 hectares. Milli watershed will be the 100 to 1000, 10,000 hectares, and micro watershed will be 100 to 1000 hectares, and mini watershed is 1 to 100 hectares. Coming to the objective of the watershed management, so the first objective is to control the damaging runoff and degradation, thereby conservation of soil and water will be happen. Second is to manage and utilize the runoff water for useful purposes, and to protect, conserve, and improve the land watershed for more efficient and sustainable production, and to protect and enhance the water resources, and to check the soil erosion and reduce the effect of the sediment yield on the watershed, and to rehabilitate the retreating lands, to moderate the flood peaks, to increase the infiltration of rainwater, to improve and increase the production of timber, fodder, and wildlife resources, to enhance the groundwater recharge wherever it is. Now let's see what are the factors which is affecting these watershed management system. The first is the we can classify these factors into the four different forms. One is the watershed characters, another one is the climatic characteristics, and third one will be the watershed operation, and fourth one will be the land use patterns. The first is these particular factors, which will be success depends on the several natural and human factors. So first is the size and shape, and second will be the topography. So topography is a landform which covers the hill, slope, and valleys affect how water will flows. The steep slopes causes faster runoff and erosion, so the flat areas allow more water to soak into the ground. So next one will be the soil type. Some soil like sandy soils allow water to infiltrate quickly. Others like clay soil hold water but may lead to the waterlogging. So the soil quality affects agriculture, water retention, and the erosion. Next is the vegetation cover. Trees, grasses, and plants help absorb rainwater and reduces surface runoff. Deforestation leads to the soil erosion, poor water retention, and the drought. And also there is in the climatic characterization, we can see the precipitation and amount of intensity of the rainfall pattern. This amount, intensity, and frequency of the rainfall affect water availability. Heavy, short burst of rain causes flooding and erosion. So the long, light rains improves groundwater recharge. And in the land use pattern and the watershed operations, vegetative covers and density will plays a major role. And poor farming methods like overgrazing or plowing slopes can increase erosion. So sustainable agriculture and proper land use may protect soil and water. And in the watershed operations, the community participation is also important. So local people involved in crucial maintaining structures and ensuring sustainable uses. So the watershed project succeed when the community takes up own ownership. So what will be the watershed management practices in the terms of purposes? It can increase infiltration, it can increase water holding capacity, it can prevent soil erosion, and we want to seek best methods and we want to acclimate it also. So the government policies and support like maintaining a laws, funding, and technical guidance from the governments or NGOs will impact the success, right? So programs like watershed development missions plays a key role. So the availability of resources like money, skilled labor, and technology may affect how well watershed management is. So here some of the watershed management structures. So the first structure is broad beds and furrows. So the functions of this particular structures is to control the erosion and to conserve soil moisture in the soil during the rainy days. So how this particular broad beds and furrows work means, so this is broad bed-like structures or the furrow system which is laid on the surroundings or the boundaries of the particular fields. So the land labels will be taken it and it will used for the animal drawn or the tractor drawn riggers. So the cost was this making this particular lays and beds furrows is like 1,800 rupees per hectare only. And what will be the key features of this particular broad beds and furrows? It will be helpful in the conservation of soil moisture. It will control the soil erosion and it will act as a drainage channel during the heavy rainy days. So this is the bed-like structures and the furrow channels. And the next structure is contour bund. So contour bund is the intercept of the runoff flowing down the slope in the embankment, and this will helpful in the controlling the runoff velocity. And the cost of this particular structure is about 1,400 per hectare. And this futures helpful in this particular watershed management will be can be adopted on oil soils and it can laid up to 6% slopes and helps to retain the moisture in the field. So this is the contour bed. So there you can see step by step structures which can be helpful in maintaining the watersheds. So the third structure is the bench terracing. And this structure will be helpful in bringing the slope land into different level types to enable cultivation. So the original slope is converted into level fields. So the vertical and horizontal intervals are decided based on the level slope. So the approximate cost for this particular structure is about 5,000 per hectare. What will be the silent features means this is mainly suitable for the hilly regions. The benches may be inward sloping to drain off excess water. The outward sloping benches will be helpful to reduce the existing steep slope to the mild one. And here we can adopt the soil with slopes greater than 6%. So this is the image which is showing this particular uh, structures of the watershed management. And the fourth one will be the micro catchments for sloping lands. So it is useful for in situ moisture conservation and erosion control for the tree crops. And the slope ranges from 2 to 8% will be useful, and we can construct this structure. And the soil type will be light to moderate structures. So the bund height will be the 30 to 45 centimeter, and it is best suitable for the dry land horticulture and the agroforestry. So the fifth one will be the check dams. So check dams is a structures which will be helpful in conservation of water, and it is a low way normally constructed across the gullies. So it is constructed on the small streams and also the long gullies formed by erosive activity of the floodwater. There we can collect the water and we can use it for the irrigation purposes also, and it will cut the velocity and reduces the erosive activity. The space between the check dams, water spread of one should be beyond the water spread of the other. Okay, so when we are constructing this particular check dams, we want to have it in mind that so the water spread of one should be beyond the water spread of the other. So the height depends on the bank height, varies from meter to 3 meter, and length varies from less than 3 meter to the 10 meter. And the cost varies from 40,000 to 1 lakh per unit when we construct this particular check dams. So this is the check dams where it can be built across the streams or the long gullies. So next, sixth one will be the percolation pond. And the function of this percolation pond is to augment the groundwater recharge. So here we can prefer the general sloping stream which narrow valley exists, adaptable where 20 to 30 groundwater levels for irrigation exist with zone of influence about 80 to 900 meters. And it will also act as a slit detention reservoir. So the cost varies from the 60,000 to 1,50,000 per unit. So this is the percolation pond where we can found it and we can store the water in this percolation. So next one will be the stone barriers. So stone barriers is a step-by-step structures where we can build the stones and we can use it for the irrigation purposes. So next one will be the integrated water resource development management, that is IWRDM. So the integration of river basin resources, surface and ground. Demands will be consumptive and non-consumptive, and also supplies facilities from the mega to the micro thing. And human and ecosystem will be involved in the this water resource development and management. And science and technology and engineering with social, economic, and synergic needs will be the part of this particular water resource development management system. So why this particular water resource development management system is important? So India land resources, irrigation and food production is the top priority, but India has 2% of the world's land and 4% of the fresh water and 16% of the population and 10% of it cattle. So having these different types of resources and vast diversity, out of cultivated area 37% is irrigated with produces 55% of the food, 63% is rain feeding producing 45% of 200-meter ton of the food. In 50 years, the ultimate proportion could be 50 is to 50 producing 75 is to 25 of 50 meters of the required food. And when you are taking about the river basin statistics, Himalayan river waters will have 300% utilizable and 1200 per BCM available. And Peninsular rivers water will have 400 utilizable and 700 BCM available. And when large dams presently stores 240 BCM, and new dams under construction should be 135 BCM. Total storage that could BCM only. Okay, so withdrawal of the water in the year of 2050, the availability will be somewhat less when compared to this. So we want to maintain the particular management system, and we want to generate the more amount of water. And by using these type of water for many purposes like drinking water, domestic purposes and municipal purposes, hydropower and other energy generation, industrial uses and navigational uses, we can use it. Where does these waters come from? So by the new dams, inter-basin transfers, groundwater, demand management, water savings, water productivity, trade and food sheds. So the watersheds can be developed, and it is will be the hydrology of the watersheds. Okay. So the watershed development have some particular parameters of the watershed like size, shape, physiography, climate, drainage, land use, vegetation, geology and soils, hydrology, hydrogeology and socioeconomics. Coming to the watershed modeling, so watershed modeling is a process of using computer-based tools or physical modes to stimulate how water flows, drains, and behaves within a watershed area. So it will help the scientists, engineers, and planners to understand the water movement, rainfall and runoff, flood risk, soil erosion, water availability, and impact of the human activities. So this watershed modeling steps will have formulation, calibration, verification, and application. And watershed model consists of input function, output function, transform function. What is the purpose of watershed modeling? So to predict the water flow patterns, to design effective watershed management structures, to manage floods, droughts, and water resources, to plan sustainable agriculture and development, and stimulate the effect of land use changes, deforestation, and urbanization. So when we are talking about the watershed models, the physical models, mathematical models, computer stimulation models are available. So here you can see the how the watershed modeling has been designed. So first, the precipitation and the interception storage will be there. Surface storage will be there. Surface runoff that directly go to the direct runoff, and the channel process will be there. And in the surface storage, directly it will be go to the interflow, and interflow directly go to the groundwater storage. So the popular watershed modeling will have several different softwares also. So SWOT, the Soil and Water Assessment Tool, HEC-HMS, Hydrologic Modeling Systems, Mike and She, this is a detailed surface groundwater stimulation, and WIP, Water Erosion Protection Projects. So the steps involved in the watershed modeling is, so first we can have the defined watershed boundary. We want to collect the data that will have the socio-economic field data, topographic maps, GA analysis and the informations, and we want to create a model. So that is the watershedment system or model we want to create. Then we want to input the data into the model. Then we want to run the simulations, and we want to analyze the results like where will the water flow will be there, how much water flow will be there, and we want to control the sedimentation levels, groundwater recharge, etc. We want to. Then we want to make the decisions whether we want to build the check dams or change the crop pattern, or we want to resize with another models like that. And the results of the International Water Association management system, it will rely on the water security, enhance agriculture yield, improve the life standard, and sustainable land use will be there, and community consensus will be also there. So this will be able to protect the flooding and drought risk, help in the optimizing water use, aids in the planning water conservation structures, supports climate range impact studies, improve the agriculture and urban planning. In simple, we can say this watershed modeling system with advanced technology will is like creating a virtual or miniature version of the watershed to see how water behaves. So we can make smarter decision for managing this particular watersheds. So thank you all. Thank you so much for listening to the watershed management. Hence, it will be implemented to renewable the resource of water. Thank you.